Hi guys, I was lately inspired by a game called Exponential Idol, where in late game you have access to chaos theory. I was amazed by it, so I decided to look at it in depth. I decided to write a Unity project where I was coding up attractors. The first one is called Lorenz attractor. This is the definition from Wikipedia page. As you can see, it has three parameters. You can tweak them as you wish during the run and it will react in real time. You can rotate the camera, zoom in, zoom out. You can zoom really closely if you would like and check how it's behaving up close. If you are changing the parameters, it sometimes goes off the limits of the originally intended intervals, so it becomes really big or changes the shape or stops doing the chaos whatsoever. You can also speed up or slow down the simulation and change the length of the trails. There is another attractor called Rossler. Again, all these parameters are named after the Wikipedia article and you can change all of them. Rossler has a different shape than Lorenz had. It's basically just a circle with a bump on it in a different axis, while the Lorenz was kind of a twisted figure 8 shape. Again, you can go nuts if you would like to. If it goes too wild, you can change back and forth between the attractors and it will just restore the default values. As for the code's perspective, it is worth mentioning how I was dealing with the simulation step size or bare set speed and the trail lines. As you can see, the speed with which the points are moving is not constant. It is dependent on the section where they are. For Lorenz, it seems to me that the further the point is from the center of the attraction areas or fields, the faster the points are moving. I also wanted the trail lines to respect the speed, the motion speed, so I introduced timestamp based trail lines with dynamic array length. This means in the areas with low speed, the trail line is moving slowly and for sure the length of the array is smaller, and in areas with high speed the trail lines are longer in count. To be able to achieve a smooth trail line, it was needed to check the distance between steps. If the step was too large, then the one step or the bigger step was split to two smaller steps of exactly half of the delta of the original step. This was done recursively, so sometimes there are subdivisions of these step times. Without this improvement, the trail lines would look really squarey, like this. This project is an open source one. I have the link in the description. I have deployed it as a Unity web application so you can have a look at it yourself. You can also compile it yourself, and I actually recommend that one because in a desktop application the anti-aliasing is enabled and it looks a lot better and smoother. Also, because of the trail lines are really thin, they are just 1 pixel lines, you cannot see the real coloring in this video. The video encoding just makes it dull, kind of. If I now zoom in, you can see the colors which they meant to be originally vibrant, and this is the way you would see if you run the web app or the local application. Okay, thanks for watching and see you next time.